This video, we'll be discussing May June 2025 paper 6.2 for probability and statistics 2. Let's have a look for question number 1. So one of a group of 3 students is to be chosen at random. So now they want us to explain how a single throw of a fair 6-sided dice could be used to make the choice. And we are having 3 students here, and then we are having 6 different score, right, for the 6-sided dice. So how can this to be used to choose the students, right? So we can assign each student with 2 numbers, which is not repeated one. All right, so each student with 2 numbers from the dice. As an example, like student number 1. Student number 1, okay, we are having the score 1 and 2. Then student number 2, maybe we are having the score 3 and 4. All right, then for student number 3, maybe we are having the score 5 and 6 for student number 3. And then if you try to have a look for the probability here, right, each student basically have equal chance. Okay, so each student has equal chance to be selected. Right, so for this case, when you're having 3 students here, basically when you throw a fair 6-sided dice, it will be a good choice okay, to choose the student, right? So as long as you did mention about the equal chance in your solution, and also maybe you have to figure out, okay, or maybe you have to explain a little bit. For every single student here, they are assigned with 2 numbers, which is not repeated one, right? Then they're having an equal chance to be selected, then it will be fine. So the answer should be in this direction, right? Okay, then after that, let's have a look for question number 2, part B. Question number 1, part B. They are talking about the time in minutes taken by the students to complete a test are normally distributed. Highlight the keyword, and then the mean is 125, variance is 50. 2 students are chosen at random. So find the probability that the difference between the time taken by these 2 students to complete the test is more than 12 minutes. Right, so the highlight the keyword difference between the time taken by the 2 students. Let's say I'm having student number 1. I'm also having student number 2. The difference between the 2 students will be x1 minus x2. The difference, right? Okay, and then now if I want to calculate the mean for x1 minus x2, basically it is the mean of x1 minus the mean of x2, and both means are coming from the original mean of the x, which is 125 minus 125, and you get a 0. Okay, and then how about the variance? So to calculate the variance for x1 minus x2, basically it will be variance x1, then plus, there's no minus for variance, yeah, so all the variance should be a plus, variance x2. Therefore, you're having 50 plus 50, and the variance for x1 minus x2 will be 100. Okay, so when they talk about difference, the symbol that we write should be x1 minus x2. Since we know that x1 is normally distributed, x2 is also normally distributed, therefore the linear combination, which is x1 minus x2, should be also normally distributed. Sorry, I should write it like this. X1 minus x2 is also normally distributed. The mean is 0 and the variance is 100. And for this question, they're asking for the probability that the difference between the time taken by the 2 students. So the probability will be what? Will be the probability of x1 minus x2. Then to complete the test is more than 12. So you should write it as more than 12 minutes. Okay, but you need to take note when they're talking about the difference, right? Besides x1 minus x2, yeah, it can be also x2 minus x1. Because x2 minus x1 is also the difference between the time taken by the 2 students. So there's another case, second case, where you're having x2 minus x1, which is also greater than 12. Okay, Since we are having the mean and also the variance in terms of x1 minus x2, what am I going to do here is I'm trying to change all my variable become x1 minus x2. So this one, no need to change anything lah. Okay, but for this one, I want to rephrase it a little bit, and you can see that it is basically x1 minus x2 smaller than negative 12. Okay, alright. Then after that, I want to change x1 minus x2 become the z because I know that they are normally distributed. So how to change it become the z? You have to take x1 minus x2 minus the mean divided by standard deviation. So standard deviation should be square root 100, which is a 10. Okay, same thing happened here. x1 minus x2, you want to change it become z, and you're having negative 12 minus the mean, standardize it, divided by the standard deviation 10 also. And from here, you'll get the probability of z greater than 1.2 and also the probability of z smaller than negative 1.2. If you try to write or draw out the diagram for the area that we are interested, okay, so we are having negative 1.2, we are interested for this one, which is z smaller than negative 1.2. We are also interested for this part where z is greater than 1.2. Since the diagram is symmetrical, right? So these two area basically is the same. You can also simplify become 2 times of z greater than 1.2. And let's calculate the probability here by finding out the table. I can only find the value from the table that I get is actually z smaller than 1.2. So let's go for the table here. Oh, let me clean it up a bit. Okay, go for the value of z 1.2. 1.2 is this one. 8849. 0.8849. But the 8849 is for smaller than. To get greater than, I have to take 1 minus 0.8849. And what do I get from here? If you try to simplify, you'll be getting 0.2302. Usually for me, I prefer to cut it short into 3 significant figure, where you'll become 0.230. Alright, yeah, so this is how we solve question. Question number 2. We are given the height of a certain species of plant denoted by HCM. The height of a random sample of 100 plants was measured, and the following results are found. The mean H bar for the sample was 80.2, and the unbiased estimates of the population variance is 15.6. Okay, and then they want us to calculate the value of the summation of H square. Alright, so just try to recall back a little bit about the formula that is involved here. When you are having the sample mean, the general formula will be the summation of H divided by the sample size n. And when they are talking about the unbiased estimate for the population variance, there are a few formulas here. One of them that is a commonly used one will be the variance. So I assume that this is the estimated variance. Unbiased estimated variance equals to 1 over n minus 1 with the summation of H square minus the summation of H square divided by n. Okay, so this is a formula that we are going to apply here in this context of the question. Okay, and now, before we can calculate the summation of H square, you realize you need to know what is the summation of the H. So to get the summation of the H, you need to get the value from the mean formula. So let's use this one. I'm having the mean of the sample equals to the summation of H divided by n. What's the mean for the sample? 80.2. And then summation of H divided by n, the sample size is 100 here. This is the 100, right? Okay. And from here, I get the summation of H, which is equals to 8020. And next one, I want to use the second formula here, the unbiased estimate for the population variance to get the summation of H squared. So let's start from here. I'm using this one, yeah? Okay. So this is the variance, which is 15.6 equals to 1 over n minus 1. So it will become 1 over 99. summation of h squared is the something that you want to find out just now, later. And then 8020 is your summation of h, and you need to square it, divided by the 100. Okay, so for this step, you just need to be very careful. Try to move the number to the other side slowly, one by one. By right, very easily, you will get the summation of h squared. And it should be equals to a big value, 644,748.4. Alright, so this question basically is quite straightforward if you know what is the correct formula to be applied, right? And this is how we solve question. Question number 3. The random variable x has a distribution of this. It is Poisson distributed. Write down an expression in terms of E for the probability of x equals to 12. Alright, so just to recall back the general formula for Poisson distribution. If you're having a x which is Poisson distributed with the mean lambda, okay, to calculate the probability of x equals to r, the general formula will be e power negative lambda, lambda power r divided by r factorial. This is a general formula that we have, okay? And now you take note that for our question here, the lambda is 15. Lambda is 15 and the r is 12, okay? Therefore, to calculate the probability, they just want us to write out the formula because they said expression in terms of E. Therefore, I'm having E negative lambda, negative 15, then 15 power 12 divided by 12 factorial. Alright, so this is the general formula for the probability of x equals to 12. Okay, in terms of E. Alright, yeah. Then let's continue further. How about if let's say they want you to, they already give you the information x equals to n equals to the probability of x equals to n plus 1. Write down an equation in n. Then hence find the value of n. So let's just start with the formula given here. X equals to n, probability equals to the probability of x equals to n plus 1. Again, by referring to the formula that we get here, yeah? Okay, so what should we have? What do we have here? Okay, so x equals to n means e negative lambda, negative 15, power negative 15, then lambda power r. So I'm having lambda power n here, divided by the r factorial, which is the n factorial for this case. Simply happen on the right hand side, e negative lambda, lambda power n plus 1 divided by n plus 1, the whole thing factorial. And from here, very easily you can see that we can simplify e power negative 15 from both sides. And now I want to group all the factorial at one side. So I'm having n plus 1 factorial divided by n factorial equals to 15n plus 1 divided by 15n. And I wish to further simplify this part. How can I simplify n plus 1 factorial divided by n factorial? As an example, let's say I'm having n is a 10. Sorry, n plus 1 is a 11. Then n is a 10. So how can I simplify 11 factorial divided by 10 factorial? Basically, you know that it should be 11 multiplied with 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, right? You can expand it become 11 factorial, 11 multiplied with 10 factorial divided by the 10 factorial. And these two 10 factorial can be simplified. And you left only 11. Okay, so simply happen here, I'm having n plus 1 factorial divided by n factorial. When I simplify it using the n factorial respectively, I'm having n plus 1 on the left hand side. So this part, I'm simplifying using some basic explanation on this. Okay, and then how about 15 power n plus 1 divided by 15 power n? So n plus 1 minus the n. We are having 15 power 1. Okay, so very easily you can see that n should be equals to 14, which is 15 minus 1. So you get a 14 here. Right, so this is how we solve question number. Question number 4. There's a bias spinner has 4 sides, and then each side is have different color, yellow, red, green, or black. The probability P that the spinner will land on the rack is unknown. The spinner was spun 200 times. And the proportion A. So we're having the proportion of getting the rate was noted. So it is denoted by A. In general, we denote it by P usually, but they just put it as A here. Okay. This proportion was used to calculate an approximate 90% confidence interval for the P. The width of this confidence interval is 0.1066, correct to 4 significant figures. Find the two possible values of A. Alright, so we are talking about the proportion. And when you're having a 90% confidence interval for proportion, what is the general formula? Okay, so if let's say I'm having the confidence interval for proportion, the general formula is P minus Z square root BQ over N. Then the upper limit will be P plus Z square root BQ over N. And if you are talking about the width, that means you are taking the upper limit minus the lower limit. When you take the upper limit minus the lower limit, then you'll get the formula 2Z square root BQ over N. Okay, alright, so if we have a look for this particular question here, we are having the width is 0.1066. So we should start from here. Okay, we are given width equals to 0.1066, and I want to replace the width by using the formula of this one. So 2Z square root BQ over N. We are having the 2. We need to figure out the Z. Okay, when we are having a 90% confidence interval, that means we are having the center area which is 90%. Then the area, the remaining area should be divided equally to both sides, and then we are having 0.05 here. This is also 0.05. So that when you total all the probability here, it is equals to 1. So that's the some idea about the confidence interval. Yeah, when you're having a 90%, this is how it look like, and we need to know the value of Z is basically this one. So to get the value of Z, you need to find out the table in the reverse way, where you're looking for the area of 0.95 and look for the value of the Z. So let's have a look for the Z for the area of 0.95. You can get the area from here, but usually I will ask the students to find out using the shortcut table first. Because from here you can see that, oh, I'm having the area 0.95 and the value of the Z is given directly, which is 1.645. Alright. Therefore, for this question that we have here, the Z should be equals to 1.645. And we replace it in our calculation for this formula of the width 1.645. Okay, then next one, square root BQ over N. Square root P, I put it as A because they did mention that it is the proportion A. Q will be 1 minus A divided by N. So what's the N for this case? 200 times. So the sample size will be 200. The N will be 200 equals to 0.1066. Okay, then maybe we need to do a little bit of calculation here. I try to move all the number to the other side. I just try to keep A and also 1 minus A on the left. By right, you will get a very long value. This is what we should have. And then if I try to expand the A, okay, then if you further simplify it, you can see that basically it is a quadratic equation for the A. But definitely this is the equation that is impossible for us to factorize it. Therefore, to get the value of the A, you need to use the quadratic formula to solve it. Alright, so we are having negative B plus minus square root B squared minus 4AC. Then divided by 2A. Right, then you just need to make sure that you try to do a little bit of calculation. You'll get two value of the A here. One of the value is 0. It's a long value lah. 2999,19409. Another one will be also another long value here, 0.7000080591. And then of course I want to carry it to three significant figure, then I will get 0.3. Another value of the A will be 0.7. Okay, so these are the two possible values for the proportion A. Right, and this is how we solve question. Okay, question number 5. The amount of time in minutes spent by a customer on one visit to a certain shop is modeled by a random variable x, which is normally distributed. In the past, the mu and also the sigma was given 10.5 and also 3.8. The shop has recently moved to a new location, and the manager hopes that the new value of mu will be greater than 10.5. So highlight the keyword greater than 10.5. It will be a keyword for us to set up the alternative hypothesis later, because if you try to read the question, they are talking about the test key. Right, so greater than 10.5 will be actually a keyword to set up the alternative hypothesis. He takes a random sample of 10 customers and notes the time they each spend in the shop. He then calculates the sample mean of these 10 times. Use a hypothesis test at a 5% significance level. The manager finds that there's sufficient evidence to conclude that the new value of mu is greater than 10.5. Stating a necessary assumption, find the smallest possible values of the sample x, the sample mean. Okay. All right. So what's the question asking for? Yeah. All right. In general, it is basically the hypothesis test. And then if you want to know in a clearer way, usually I will tell students, once you know that it is a hypothesis test question, you try to write out the null and alternative hypothesis first. So for this question, I know that my mu is 10.5 equals to 10.5 minutes, right? For the null hypothesis, and then the alternative hypothesis based on the keyword of the greater than. So I'm having mu greater than 10.5 minutes. Okay, so I carry out the test at 5% significance level, and then there's a conclusion here. Manager finds that there's sufficient evidence to conclude that the new value of mu is greater than 10.5. According to what we have in this particular sentence, sufficient evidence to conclude mu greater than 10.5. That means this is correct, this is a conclusion, and this is not correct. Okay, so now they want you to find the smallest possible value of the sample mean. Okay, so what are we using for sample mean here? Basically, the sample mean is used to carry out the test, because we're using the sample mean to calculate the test statistic. Okay, alright, then after that, I want to know what's the smallest possible value for the sample mean so that I can make this conclusion. Okay, and now according to the distribution that we have here, we know that we are going to test about the population mean, right? So it is originally normally distributed, and this is a one-tailed test. Therefore, I'm having a rejection region on the right-hand side. And this rejection region will be 0.05. This is 0.95. Okay, and now they said they reject the null hypothesis, and what's the smallest possible value of sample mean for us to reject the null hypothesis, because we conclude that this is correct, this is wrong, right? Okay, that means we already reject the null hypothesis. So they're asking for the smallest possible value of the mean, sample mean, okay, to reject the null hypothesis, which means that they ask us to find the rejection region. Okay. Yeah, so this question basically it looks like not so obvious. Yeah, there's no very obvious keyword, but basically they are asking for the rejection region, because they are asking what is the smallest possible value for the sample mean, so that you can make this conclusion. Okay, so that means they're asking what is the smallest possible value of x, so that you can reject the null hypothesis. Alright, so basically they want us to find the rejection region. And we know that for the rejection region, this is 0.05, right? What is the value of the z, or the critical value for me to reject the null hypothesis? So we have to look for the value of the z by looking at 0.95. So again, I will go down to the shortcut table here, 0.95 area, we are having the z 1.645. Okay, so I know that my z here is 1.645, and we reject the null hypothesis when the z value is greater than 1.645. And what is the test statistic formula when we want to carry out the test for the population mean? Okay, the general formula is you are using the sample mean minus the population mean divided by standard deviation over square root n. And this is greater than 1.645. Put in all the value that we already know here. Sample mean, of course, I don't know. Population mean, I know is 10.5. Okay, so what's the sigma, the standard deviation? Standard deviation is 3.8. And this is actually our assumption here, divided by the square root n. So the square root n will be sample size. Where's the sample size here? 10 customer. And then greater than 1.645. And basically, there's an assumption here that we are using. And we need to write it out as requested by the question. The value 3.8 here, basically, we are making an assumption, okay, where the standard deviation value remains the same when I'm using the sample here. Okay, remain the same or unchanged. Right, so this is the assumption that you should write out in your calculation, because the question did ask you to list out, right? What is the assumption that you make here? Right, so our assumption is we are assuming that the standard deviation when we carry out the test is the same as the population standard deviation, right? Then greater than 1.645. And if you try to move all the numbers slowly to the other side, eventually you will get the sample mean, which is greater than 12.5. And this is basically the smallest possible value of the sample mean. Okay, if you are still having some other value less than this particular value 12.5, then basically your conclusion will be different. The conclusion will be accept the null hypothesis already, right? Yeah, and this is the assumption that you shouldn't forget to write out in your answer here. Okay, yeah, so this is how we solve this question number 5. Okay, question number 6. Use a suitable approximating distribution to answer the following. We are having a random variable w with the distribution of binomial, and then they want to find the probability of w greater equals to 4. Okay, keyword is approximating. That means I cannot use the binomial to do the calculation. I have to change it, become some other distribution. Alright, when we are having a variable x which is binomial distributed, in our A2 syllabus instead, we can change it become Poisson, where the lambda of Poisson is n times p, which is the mean from the binomial distribution. And what is the condition for us to change binomial become Poisson? So the condition, there are two here. The first one is n must be greater than 50, and secondly, you need to make sure that the np is smaller than 5. Okay, so this is the condition that we can change binomial become Poisson distribution. And if you have a look for this question, basically this is what we have. We are having w, yeah, not x. Okay, so let's put it as w. Is binomial distributed with 700 and also 0.005. and we will want to change become Poisson. So to get a lambda for Poisson, you are taking 700 multiplied with the p in and you'll get 3.5 here. Okay. Okay, so 3.5 basically is 700 multiplied with 0.005. And to calculate the probability of W greater equals to 4, so what do we have? Okay, so same thing happened here. I just help you to recall a little bit. For a Poisson distribution, what is the formula for x equals to r? To calculate the probability, it will be e negative lambda, lambda power r divided by r factorial. Okay, same thing happened for our case here. Our lambda is 3.5. Then r. Let's have a look what do we want from here. So w greater equals to 4, that means you have to start from w equals to 4, w equals to 5, w equals to 6 until infinity, which is impossible for us to do the calculation. Therefore, we have to take 1 minus r. W greater equals to 4 means that the 4 should be included. When you want to minus, you shouldn't include the 4. So you are going to calculate 1 minus W smaller than 4. W smaller than 4 means that you start from W equals to 0, W equals to 1, 2 until 3. Not included the 4, yeah? Okay, so for the first term, I'm having E negative lambda. So the lambda will be 3.5. I'm doing a shorter way of the formula, okay? I just try to factorize out the E lambda, E negative lambda for every single term. Then the calculation will be easier for me now when I want to press the calculator, right? Okay, when x is equals to 0, you're having lambda power 0 divided by 0 factorial. Anything power 0 divided by 0 factorial is always a 1. When x equals to 1, you're having lambda power 1 divided by 1 factorial, which is always a lambda, so 3.5. When x equals to 2, you're having lambda power 2 divided by 2 factorial. X equals to 3 will be lambda power 3 divided by 3 factorial. Okay, then after that, just try to press calculator a little bit. By right, you should be having 0.463. Correct to 3 significant figure as your answer. Alright, then let's continue to part B. There are two values of W are chosen at random. Find the probability that the sum of these two values is less than 3. Sum less than 3. Alright, and I know that now my W is Poisson distributed with the lambda 3.5, right? When I'm having the sum, means W plus W. When W plus W, it is still Poisson distributed, but the lambda, you have to add 3.5 with 3.5, and your new lambda will become 7 for the variable of W plus W. And what are they interested? They said the sum of these two values less than 3. Therefore, when I want to write out the probability, the symbol, it will be W plus W less than 3. Same thing happened here. You should start from W plus W equals to 0, then equals to 1, then equals to 2. Shouldn't include the 3 here. Again, for the step, I always prefer to figure out or factorize out the e power negative lambda first. Lambda power 0 divided by 0 factorial is always a 1. Lambda power 1 divided by 1 factorial is always a lambda. So this is the term x equals to 0, W plus W equals to 0, W plus W equals to 1, W plus W equals to 2 will be 7 squared over 2 factorial. Okay, then of course you try to press calculator for this by right. Your answer should be 0.0296, correct to 3 significant figure. And this is what we have for 6A part 2. And let's continue to 6B. Okay, for 6B, now we are having a random variable x with the distribution of PO 200 Poisson with the lambda 200. use a suitable approximating distribution. So again, we see another keyword approximating to find this probability. Okay, then now in our A2 syllabus, for Poisson distribution, we can change it become normal distribution. Both the mean and also the variance are the same, where they are both lambda. Okay, mean is equals to lambda, variance is also equals to lambda. What is the condition for us to change Poisson become normal distribution? The general condition is the lambda is large, which is greater than 15. Then you can change it become normal. Okay, then a small reminder here, when you are doing the approximating from Poisson to normal, Poisson is discrete random variable, normal is continuous random variable. Therefore, you have to apply continuity correction. Usually I put it as CC lah, continuity correction is either a plus 0.5 or minus 0.5 in your variable. So let us start, yeah. I'm trying to have x is Poisson with original lambda 200, and I want to make it become normal distribution. Mean is 200, variance is also 200. I want to calculate the probability for x greater than 205. So first step, please make sure that you do continuity correction. Okay, so try to imagine there are a few lines here in the Poisson distribution. You're having 203, 204, 205, 206, and so on. When they are mentioning about greater than 205, that means when you start to calculate the probability, you should start from 206 in the Poisson distribution. So start from 206 and more, right? So it should be on the right hand side here. These are all the probability that you want to count. And to apply continuity correction, you have to make sure that the line or the value that you want to include is slightly before the area that you want to find. So 206, the line before should be 205.5. And this will be a continuity correction. Okay, so x greater than 205.5 here. Alright, so after you apply the continuity correction, you know that now you're having normal distribution for the x. To calculate the probability, of course, you have to standardize it, become the z. How to standardize it? Please make sure that you show it out minus the mean. Mean is 200 divided by standard deviation. So the standard deviation should be square root of 200. Okay. Calculate the value for the z up to 3 decimal places. It should be 0.389. To get this particular area, z greater than 0.389, you have to take 1 minus 0.389. So where's your 0.389 here? Looking for 0.38. Then 9. So please take 6480 plus 34. We should be having 6514. Okay, but this is smaller than 0.389, but we are interested to look for the value greater than 0.389. So you have to take you have to take 1 minus 0.6514 to get the final area that we want. Okay, so we are getting this 3486. But of course, I will correct it to 3 significant figure where it will become 0.349. Okay, so this is how we solve question number 6. Question number 7. We are given the random variable x where with this PDF, and then the x is defined from 0 until a, with the function of kx squared divided by a squared, where k and a are positive constants. So I think this is an important info that you need to know. Show that k equals to 3 over a. Right, when we want to find any constant or any unknown from the function in the continuous random variable, basically you need to know that there's one very useful information where if you try to integrate the value for the limit with all the x, for the function, it is always equals to 1. Okay, so this one is very helpful for us to find out the maybe the unknown or maybe the constant term that we want to find out in the function itself. Okay, so now we want to find the k, right? So to find the k, I have to integrate all the value for the x, that means from 0 until a, for the function of kx squared over a squared dx, and I let it equals to 1. Okay, so for me personally, I always prefer to take out all the constant when I apply any integration or whatsoever lah, because I feel that it is easier. Or maybe when I try to simplify my equation, it looks more simple. Integrate x squared, you'll be having x power 3 divided by 3. Then I have the limit of a and 0, and I let it equals to 1 again. K can be written as 3a squared. I take out the 1 over 3 from the integration. Substitute the a inside my function. Here I'll be having a power 3 minus substitute the 0, I'm getting a 0. Okay, so from here when I try to simplify, I'll be having k, then I'm having a over 3 equals to 1. So this is how we get the value of k, where it is equals to 3 over a. Right, yeah, so this is how we get the k. Okay, then let's continue to the next part. So for the next part is part B. Now it's given that ex is equals to 1, find the value of the a. Alright, then how are we going to find the expected value in a continuous random variable? So the idea is basically you need to integrate all the value of x also that the function is defined. You have to multiply the x together with the function before you can integrate it. Alright, so this is a general formula to find out the expected value of the x when you are having a continuous random variable. And we are going to apply it here. Okay, we know that the expected value of the x is equals to 1, which means that if I try to integrate my function from 0 until a, then multiply the x with the function fx, which is kx squared over a squared, and it is equals to 1. Because the mean given is 1, right? Expected value is a 1. So I let it equals to 1 here. Okay, what can I do now is I try to take out the k and also the a squared. If I want to take out the k and a squared, because both of them are constant, so I'm having k multiply with 1 over a squared. Then I'm having x power 3 dx equals to 1. Okay, why I want to separate out the constant here for the k and also 1 over a squared is because of I want to substitute the value of the k. Just so I know that k is equals to 3 over a, right? So I put 3 over a here, multiply with 1 over a squared. Then I start the integration for x power 3. When I integrate x power 3, I will be having x power 4 divided by 4 with a limit a and 0, then equals to 1. Okay, try to simplify everything. I'll be having 3 over 4a cubed. Substitute the a inside the x. I'm having a power 4 minus the 0, and it is equals to 1. If I try to further simplify this part, you can see that a power 3 and a power 4 can be simplified. And I'm having a equals to 4 over 3. Right, yeah, so this is not very hard, not very complicated. Just make sure that you know how to integrate and get the value for expected value for the x correctly. Okay, then let's continue further. Let's have a look for part C. For part C, they want us to find the median of x. And you need to know to find the median, right? You should know that when we try to integrate from 0 until median, the m here I put it as median, yeah? I assume that the m here is median here. When you integrate from 0 until median, means that from the lowest value that the x is defined until the median, I shouldn't put a 0 here. Actually, I should put the negative infinity, which means the minimum value or the minimum x. The minimum value that the x is defined. Okay, all right. So no matter how, up to you. Okay, so some book they will put it as negative infinity. When you try to integrate the negative infinity until the median, right, for any function, it will actually cover 50% of the data. So usually put it in this way, where we integrate from minimum value until the median for the function fx defined, I'll let it equals to 0.5. Okay, that's one way. Another way is, some students might prefer to take median, integrate the median until the maximum value for the x for the particular function also. Then it is also equals to 0.5, because median means the center location of the whole set of data. So that means if you integrate from smallest value to the median, or from the median to the maximum value, it will consist 50% of the whole area, the whole data. Alright, so that's the reason why we make it equals to 0.5. And we are going to apply it here. For me, I'm using the minimum value one. Alright, because my minimum value start from 0 lah. To me, it is easier for us to apply and substitute the value 0 later. Okay, right. So let's have a look here. I want to integrate from 0 until median for my function fx. So again, what's my function fx just now? It is actually k, where is it? Okay, it is actually kx squared over a squared. Right. Okay, so I want to integrate my function kx squared over a squared dx, and I let it equals to 0.5. Again, I will take out the k, I will take out the 1 over a squared, and I only want to focus on the integration of x squared. Okay, but before that, since I already know the value of the a, right? So I try to substitute all the value here for the value of a first. K is 3 over a. 1 over a squared is 1 over a squared. What's the value of a that we get just now? It is 4 over 3, right? So you'll be having here 3 divided by 4 over 3 cubed. And what's the value that you get here if you simplify the value for the a? Okay, if you didn't do any careless mistake, by right, this part you will get 81 over 64. Okay, then I start the integration for the x squared. I'll be having x cubed divided by the new power 3. Put in the median and also the 0, and I got 0.5. Okay, so further simplify all the terms that I have here, I'll be having 27 over 64. Take out the constant 3. Okay, the constant 1 over 3, I take it out. Substitute the median. Here I'm having median power 3 minus 0 power 3, and it is equals to 0.5. Okay, then of course I need to do a little bit of calculation using calculator. I need to take the cube root of 24 divided by 54. Then of course you can further simplify if you want. Then I have to take the cube root, where later your value of the m should be 1.06, correct to 3 significant figure. Right? Yeah, so this is how we solve question number 8. So who is this? I don't know how to pronounce the name. Birgit, okay, has a 6-sided dice. She suspects that the dice is biased, so that the probability P that will show a 6 on one throw is less than 1 over 6. Highlight the keyword less than 1 over 6. If this is a hypothesis test, then the less than 1 over 6, the keyword less than, will be your keyword to set up alternative hypothesis. She throws the dice 30 times and find that it shows a 6 on exactly 2 throw. Highlight the keyword exactly 2 throw. The 2 throws here basically is also the observed value for you to calculate your p-value later if you want to carry out the test. Alright, use a binomial distribution. And for this question, they did mention clearly that you have to use a binomial distribution with a 5% significance level to test her suspicions. Okay. Alright, so first of all, we need to set up the null and also the alternative hypothesis first. They are talking about the probability of getting a 6 on the dice. Okay, so originally, if let's say the dice is fair, so the probability should be 1 over 6. But they suspect that it is less than 1 over 6, less than. So the keyword less than means that the p will be smaller than 1 over 6, and we'll put it under the alternative hypothesis. Okay. Alright, then after that, for this question, because they already mentioned clearly that we have to use a binomial distribution. Therefore, I'm having x is binomial distributed. What is the total number of throws? It is 30 times. And what is the p? The p, we are using the null hypothesis value of the p, which is 1/6. Okay, and to carry out the test, she throw the dice for 30 times, and what's the observed value that she get? She get 2 throw of a 6. Therefore, the 2 here will be actually our observed value to help us and calculate the p-value to carry out the test. The p-value means the probability lah. Okay, when I'm having x equals to 2, exactly 2 throw, I cannot find out x equals to 2, because to calculate the probability, all our rejection area should be on the left hand side or either the right hand side of the graph. When we are having p smaller than 1/6, that means our rejection region will be on the left hand side. Okay, and to calculate the probability for the p-value on the left, you have to use x smaller equals to 2, but not x equals to 2. It has to be smaller equals 2, because I want to know what is the area for smaller equals to 2. Is it bigger than the significance level or not? Okay, or is it smaller than the significance level? We have to calculate the area, right? So we have to calculate smaller equals to the whole area on the left, but not one particular line or one particular probability on the left, right? It should be the whole area. Therefore, you must have x smaller equals to 2. Okay, if I'm having binomial distribution, of course, we have to use binomial formula lah. So x smaller equals to 2, you should start from x equals to 0, x equals to 1, and also x equals to 2. So x equals to 0, I'm having this 30c0, 1/6 power 0, 5/6 power 30. Then 30c1, 1/6 power 1, 5/6 power 29. Then the next one will be x equals to 2, 1/6 power 2, then 5/6 power 28. Alright, then we try to use calculator to help us a little bit for this question. By right, the value that you get should be 0.103. And this is basically your p-value. We want to compare it with our alpha. Our alpha is greater than 0.05. Okay, so just for your information, this particular part is the p-value, and this is our alpha, our significance level. Before we can make any conclusion, right, we have to write out a comparison statement where our p-value is 0.103. It is basically bigger or larger than the alpha, which is 0.05. And what's the conclusion that we should make? Like what I showed you just now, right, we have a graph like this, but this graph cannot be shown in the real exam, okay, because it is not a correct graph, but it is just a reference for us to visualize the whole question. Okay, assume that this is a binomial distribution graph or the bar. I'm having x equals to 0 and the x equals to 30, right? The probability of x smaller equals to 2 is this one, which is bigger than 0.05. That means if I want to draw my area, the 2 should be somewhere here, so that the area that I find x smaller equals to 2 is the black color area, which is bigger than the green color area 0.05. Okay, and then from here you can see that the line of the 2 basically falls under the acceptance region. When you have the 2 falls under the acceptance region, basically you do not reject the null hypothesis because it is under the acceptance region, right? So what we do have here is we do not reject the null hypothesis. Okay, and after that, what is the conclusion here? So that means there's insufficient evidence to support the girl's suspicion. Okay. All right. Yeah. So this is generally the conclusion for the test that we carry out here. Okay. All right. Then let's continue to part B. For part B, now she said that she carries out a similar test at 5% significance level, still 5%, under another 30 throws of the dice. So that means she try to carry out another dice, another experiment, okay, by having 30 throws. So calculate the probability of a type 1 error. Okay, so how can we carry out the type 1 error again? Right, so first of all, we need to know that what is the distribution for this question again. It is still binomial distributed with 30 throws, and the P is still using 1 over 6. Why we are still using 1 over 6 here? Because we need to know what is the definition for type 1 error first. So for type 1 error, basically the definition is you reject the null hypothesis when the null hypothesis is true. And when you want to calculate the part of reject the null hypothesis when the null hypothesis is true, right? You need to find out the rejection region first. But our problem now is we actually don't know where is the rejection region. Okay? Alright. Therefore, we need to use our previous test to help us a little bit. Okay? So let's have a look for this question here. Just now we tried to carry out the test, right? And this is the unofficial diagram that I draw. And I say that actually we cannot draw this in the real exam because it is not a correct graph. But to me, it is very helpful one. Okay, so why is it helpful? So let's have a look for the result that we have just now. When I try to calculate the value of x smaller equals to 2, we know that the 2 falls under the acceptance region. Okay, so if I try to calculate the probability for x smaller equals to 3, definitely the 3 is under the acceptance region also, because when you add the probability, it becomes bigger and bigger, the area. So there's no point that we try to figure out the x equals to 3. So to get the rejection region, we need to try and error a little bit. Now we want to see if let's say 2 is under the acceptance region, then how about the 1? Will the 1 falls under the acceptance region, or the 1 will falls under the rejection region? We don't know. So you need to figure out whether the 1 falls under acceptance or rejection region. Therefore, what are we going to do now is we try to calculate the probability of x smaller equals to 1. Okay? Yeah, but maybe to avoid confusion, right? Maybe I try to skip the type 1 error first. So now my aim, my target is to find the rejection region first. Alright. Okay, so to find the rejection region, I try to find out x smaller equals to 1 first. Okay, so to get the x smaller equals to 1, I'm having x equals to 0. That means 30C0, 1 over 6 power 0, 5 over 6 power 30. Then 30C1, 1 over 6 power 1, then 5 over 6 power 29. When I try to find out the probability for this one using calculator, by right I'll be getting 0 0.0295. Correct to 3 significant figure. Okay, and now I want to see whether my 1, x equals to 1, falls under acceptance or rejection region. The area that I get is 0 0.0295. Compared with 0 0.05, it is smaller, right? The 0 0.0295 is smaller. That means if I want to draw the 1, the line should be somewhere here, so that the red color area, which is x smaller equals to 1, is smaller than the 0 0.05. And very obvious, you can see from here, the line number 1 falls under the rejection region. 2 is acceptance, 1 is rejection, 0 definitely is under the rejection. Therefore, you know that your rejection area or rejection region falls under x smaller equals to 1. Okay, Alright, then now, once you get the rejection region, only you start to find the type 1 error. So what's the type 1 error here? You reject the null hypothesis when the null hypothesis is true. And what is your rejection region? Reject null hypothesis means you have to put in your rejection region. It should be x smaller equals to 1, where your p is equals to 1 over 6. Because null hypothesis is true, means that your p is still equals to 1 over 6. When you try to find the probability here, right? X smaller equals to 1 using p equals to 1 over 6. If you have a look here, the step is basically exactly the same like what I have here. Alright, therefore, your type 1 error is basically 0.0295. You don't need to calculate the step anymore because you have already calculated just now when you try to figure out the rejection region. So you can directly copy in the answer because the step for this particular part is exactly the same like what I did just now. Alright, so you can just directly copy the answer and our type 1 error is 0.0295. Okay, right, then let's continue further for part number C. Now they are saying that I'm having the value of P is actually 0.02. Calculate the type 2 error probability. Okay, so to calculate the error, type 2 error, for the probability for type 2 error, let us try to list out or write out the definition first. Type 2 error means what? Means that I accept the null hypothesis when the null hypothesis is false. Okay, where is my acceptance region? Accept null hypothesis means that I have to put in the acceptance region. Just now I know that my rejection region is x smaller equals to 1. Therefore, the acceptance region will be x greater than 1 or x greater equals to 2. Because just now 0 and 1 belongs to rejection region, so start from 2, 2, 3, 4, 5, 6 onwards, it will be the acceptance region. When they say null hypothesis is false, that means you cannot use p equals to 1 over 6 anymore. You have to use p smaller than 1 over 6. But there are so many possible values that you can use when p is smaller than 1 over 6. Therefore, in the question, they will definitely give you a new value of p when they want you to calculate the type 2 error. Alright, so for the part p smaller than 1 over 6, they actually want us to use p equals to 0.02. So please put in the value p, which is 0.02. And usually if I don't want to make myself confusing, right, I will always write the distribution again beside it so that it reminds me myself. Now I'm using the n is 30, but the p is 0.02. How to use a binomial distribution to calculate the probability for x greater equals to 2? You have to start from 2 until 30, one by one is very long. So we prefer to take 1 minus x equals to 0. So 30 C0, 0.02 power 0, 0.98 power 30. Then also minus x equals to 1. So 30C1, 0.02 power 1, 0.98 power 29. Okay, then should you minus x equals to 2 or not? You shouldn't, because x equals to 2 belongs to part of the acceptance region, right? So when you want to minus, you only minus the 0 and also the 1. Okay, then again, try to use calculator to help you. By right, you should be getting a super long answer also. Then don't forget to cut it short into 3 significant figures for your final answer. So what do you get here should be 0.121. Yeah, so this is how we solve question number 8. And this is the end of the video. Thank you very much for watching this video.